This is Michael Klein from Stanford University Libraries, and I'll be demonstrating Argo, the administrative discovery interface for Stanford's Digital Object Registry. The most important aspect of Argo is that it presents a consistent, aggregated view across a number of different collections and content types, including content created by several different Hydra and non-Hydra applications. In order to make it easy to find the particular content we're looking for, Argo features keyword searching as well as a number of facets. We can limit our search by object type, content type, the administrative policy governing the object, or the collection the object belongs to. In addition, we present a hierarchical list of tags that can be attached to any object at the time that it is registered. For example, a particular type of book, or the name of the project the object was registered under. Let's select the Kitai topographic map project. The first thing we see is a standard result view showing identity and administrative information about each object. Clicking through to the detail view, we are presented with more detailed identity information, along with an object thumbnail, a list of Fedora data streams, information about the object's digitization history and workflow state, and a list of resources and files that make up the object's content. We can view the object's descriptive metadata crosswalked to Dublin Core, either in tabular format or in raw XML. As well as the contents of the data streams themselves. There's also a list of links to external representations of the object in Fedora itself, and for completed projects, a link to the public view in the digital stacks. Often, a project manager or scanning lab staff will prefer a tabular view of a particular set of objects. Argo's report view shows a live updating grid limited to the current search, with movable, selectable, and resizable columns. The entire report can be downloaded as a comma-delimited file for more in-depth analysis. Argo can also be used to investigate details about an object's workflow status. We can filter by different aspects of the digital object lifecycle and also by specific workflows, processes, and statuses. For example, drilling down into the accessioning workflow within the content metadata validation process, we see that there are 5 errors. We can rotate this facet to show the 293 errors within the accessioning workflow, and that 5 of them are in content metadata. One more rotation reveals just over 3,000 workflow errors, with 293 of them in accessioning and 5 in content metadata. This information is also available in grid form, allowing us to jump straight to the fact that there are 5 errors on the content metadata process of the accessioning workflow. If we bring up the first item showing an error, we can click the accessioning workflow to see a detailed process and status list and the explicit error that caused the process to fail. If we choose, we can reset the status to waiting to try again. We can also view the workflow as a directed graph, so we can see exactly which process failed and which processes are blocked by the currently failing process. Finally, let's move on to a demonstration of item registration. Argo was designed to allow bulk registration based on metadata pulled from Stanford's online catalog or other sources. The operator fills in the project name, selects an administrative policy and a starter workflow, and enters some identifying information. Argo retrieves and stores the proper metadata, assigns unique digital object identifiers, and initializes the Fedora objects. Future plans include allowing Argo to add and edit data streams, update embargo information, perform batch updates to objects and workflows, and more.